lesson. So this lesson will be available to you as soon as class ends today in our pink folder. So let's go ahead and get started. If we would please, let's look in our notes, and I want to remind us, we want to make sure we remember that Earth's winds and ocean waters all move according to the law of convection. We want to remember the law of convection states heat always rises and cold always sinks. This is a review, guys. You don't need to write these notes, okay? So when we start talking about air masses and all of those things, it's important for us to know that an air mass is a huge body of air that has one type of temperature and one kind of moisture inside of it. And what kind of temperature and the level of moisture that an air mass has is depending on its location, okay? Remember, it can be a maritime polar, maritime tropical, continental polar, or continental tropical air mass. Here's more of a throwback. We also talked about our polar jet stream. Remember that polar jet stream is born in the polar region, specifically in the Arctic. And that polar jet stream is a fast-moving ribbon of air that will dip down to the United States, certain parts of the United States, but what can move that jet stream up or down is the amount of heat near it. Remember, heat's like a bully to the polar jet stream. The polar jet stream won't go anywhere near heat. So if there's a heat wave in a certain state where the polar jet stream would usually go, it now won't dip that low, okay? So we want to make sure we understand that polar jet stream is so important because not only does it bring cooler temperatures, but it also brings moisture and precipitation. Remember, we also wanted to remember our ocean currents, those two types of ocean currents. The Gulf Stream current, it brings hot water from the tropics up, okay? And then our California current, it brings cold water from the polar region down. That's still following the law of convection. So let's get started here. And we're going to finish talking today about the relationship between air masses and their boundaries. Air masses and their boundaries. Please write this heading in your notes. This is a part of your new notes. Air masses and their boundaries. We want to remember that an air mass is, there we go. Sorry, y'all. An air mass is a large body of air. And so if I'm going to draw, let's say I'm going to draw a continental polar air mass. Okay? And we're going to label this continental polar, or abbreviated little c, big P. The continental polar air mass, we know that's a very cold and dry air mass. This boundary around my air mass is cold. So we would call this a cold frontal, oh goodness, sorry y'all, a cold frontal boundary. Whatever you see Miss Neville writing right now, you want to write as well. This is a cold frontal boundary. Or you'll hear the meteorologist on your mom and dad's TV say, this is a cold front. Okay, we know this is a cold front because it belongs to that continental polar region. Okay, and so that boundary around it is called a cold frontal boundary, or in short, a cold front. Now, let's say we have a continental tropical air mass, a continental tropical, there we go, air mass. We know that continental tropical air mass is going to be warm and dry. So that boundary around it, is called a warm frontal boundary or a warm front. And that's what we're going to be talking about today, guys, is what is a front? Why are they important? Like what weather comes along with them? And how do meteorologists, weather scientists, how do they share with us that a front is near us or coming near us? We're going to look at cold fronts and warm fronts, stationary fronts, and occluded fronts on a weather map today. Please take some time to finish writing this down. It may be important that you use the same colors Miss Neville has used. Miss Neville will go on at 8:23. You've got 2 minutes. You got about a minute left. All right, so let's go on. Reminder, this lesson is being recorded if Miss Neville goes too fast for you, okay? So let's talk in our notes. Let's write this down. What is a front or frontal boundary? What is a front or frontal boundary? Remember, like we just drew, a front is the boundary around an air mass, that continental polar, continental tropical air mass, okay? We want to make sure we know that an air mass or a front has a specific temperature. It's going to either be cold or warm or cold. Okay, and the fronts function by moving using that law of convection. That law, though, just like any law, as we'll discuss at the end of our lesson today, that law can be broken. And so when that law is broken, just like if someone breaks a traffic law, an accident could happen. So that's the same thing that can happen here in weather. When natural laws are broken, severe weather happens. And we want to make sure we understand there are 4 types of frontal boundaries: a cold front, a warm front, a stationary front, and an occluded front. Please take 2 minutes to finish writing these things down. Miss Neville will go on at 8:27. Miss Neville is going on at 8:27. One second, guys, I'm going to let a student in, and I've stopped sharing my screen so we can get that student in. I'll give you an extra minute to finish your notes. I'll email that student and let her know it's not letting her in. All right, back to work. 8:28, Miss Neville will be ready to go on. Couple more minutes, couple more seconds. So in your notes, this chart needs to take up a full page. It may be a good idea for you to turn your notebook horizontally like this, not vertically, but horizontally like this, and fill up this page. The rest of our notes will go on this page. Now, here's some things you want to know when you're creating your chart. Notice how Miss Neville's made some columns more fat than other ones. The row that says, how does it form? This row needs to be pretty big because you're going to be drawing some pictures there. The associated weather conditions column doesn't have to be very big. Okay, you're going to have maybe 7 words in those boxes, so that column doesn't have to be big. And the weather map symbol also needs to be big, but it doesn't need to be as big as this column. I'm going to help you out and let you know where you need to write your notes today, because when I am talking about associated weather conditions, I'm going to underline it in green. When I'm talking about, when I'm telling you to write it in the how does it form box, I'm going to outline it in orange. And the weather map symbols, so you'll know what box to put those in when we're looking at our notes today, Miss Neville is going to outline them in yellow. Take some time to finish creating this chart. Now you see at the top, there are 4 types of frontal boundaries that we as 6th grade South Carolinian scientists need to know about, because these are the fronts that affect the United States the most, okay? So we see warm front, cold front, stationary front, and the occluded front. Please take some time to finish drawing this chart. This chart should take up the entire page, an entire page in your notes. Please start finishing up. Okay, so let's start talking about our first. Let's start talking about I think the cold front comes first. So we're going to be writing in, I think, this column first. We're doing the cold front first. I'm pretty sure. Yep. So a cold front. A cold front. We want to, in our box that says, how does it form under cold front? We want to draw this picture. We want to draw this picture in the box for cold front that talks about how does it form. We want to make sure we understand that a cold front forms when a large cold air mass pushes a less powerful warm air mass up and away. So I want you to think about a fighter, a really strong boxer that basically looks like Terry Crews, really big muscle guy, and then think of a toddler. So between Terry and a toddler, if they were to ever fight, who would win? It would be Terry Crews. In this case, that large muscle, the most powerful, is the cold front. That cold front is more powerful, so it's going to push that warm air mass up, 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 and away. This leaves room for the cold weather to come in, along with some precipitation. So, the associated weather conditions here. The associated weather conditions here, we need to write in the box that says what associated weather conditions. We need to have here that it's going to bring colder weather and precipitation. colder weather, and precipitation. Remember, this is where that big picture is going to go in that fat row that you created. Okay, we want to make sure we know that that cold air mass is more powerful, and it's going to push that warm air mass that's much weaker. It's going to push that warm air mass up, up, and away. Please take some time to finish writing this down. And we've not done the weather symbols yet. Weather symbols will come at the very end of this lesson today. Remember, if you don't get to finish this picture during the live session, all of these notes are in the pink folder where Ms. Neville showed you at the beginning of class. So let's move on to a warm air mass. It's important for us to know that the warm air mass is basically the opposite of a cold front. So that a warm front is where the warm air is more powerful than the cold air. And that warm air is going to push that cold front down and away. Remember, cold air sinks according to the law of convection. So it's going to push that air down and away. We want to know that the weather that's associated with this area, with this kind of warm front, is warmer weather and precipitation. Warmer weather and precipitation. Remember, if Miss Neville goes too fast, you will be allowed to, this lesson is being recorded right now. So you'll be able to pause us and be able to finish your picture, write down anything important here that you need. A stationary front. Here's the battle royale. We've got two very strong air masses, both equally as strong. So what we'll find here is that a stationary front brings warm weather for a long time. Not only does it bring warm weather for a long time, it brings lots of rain. This rain stays for days on end, sometimes a week. So a stationary front brings warm rain for a long period of time. Ms. Neville is emphasizing how I'm saying that because it's going to be different than the kind of weather that comes with an occluded front, our last front that we'll be able to talk about today. When we're talking about the stationary front, it's important for us to know that the stationary front is when a cold front and a warm front meet each other, and neither one of them is going to be pushed. I'm not going anywhere. Okay? You move. No, you move. No, you move. So this standoff takes a long time. And so because this standoff lasts so long, it brings lots of warmer rain for a long time. With a stationary front, if you don't remember anything else Miss Neville says today, a stationary front brings precipitation for a long time. A stationary front. We see both of those the cold front and the warm front standing off. Neither one of them will move. Because of that, it brings warm weather for a long time. Warm, rainy weather for a long time. Okay, so let's keep going here. An occluded front. An occluded front is very similar to a stationary front with some very key differences. Occluded fronts don't usually happen here in South Carolina. They do happen often in Texas, where tornadoes form. Occluded fronts happen fast. An occluded front is when a powerful cold air mass out of nowhere pushes in, and it pushes a warm front out of the way so fast that some of those temperatures mix. Yes, the cold and warm air begin to mix, making cool air shoot out. So an occluded front happens very fast, and because of this, thunderstorms and things happen. What we see here is this is breaking. The occluded front breaks the law of convection. Yeah, heat's not rising here. Heat's getting mixed in with cold. When a law is broken, bad things happen. True here in this law of nature, when the law of convection is broken in weather, severe weather, like thunderstorms or tornadoes occur. So the biggest difference between a stationary front and an occluded front is time. Yes, we want to make sure we know that a stationary front, two very powerful air masses stare at each other. Neither one of them will move, both equally as powerful. The occluded front, the cold air mass is more powerful, and this bad boy swoops in and he pushes the warm air out of the way, but it happens so fast that some of those temperatures mix. So when those temperatures mix, cool air is created, the law of convection is broken, and then we see severe weather occur. In your notes, if you would please make sure that you have there it is. This front brings severe weather like thunderstorms and or tornadoes. Usually whenever you see a thunderstorm, that's where a tornado is going to come from. Tornadoes usually don't occur. I'd say mainly don't occur without the presence of a thunderstorm. Okay. And these happen fast. Just like tornadoes don't last for hours in one area, they last for seconds. Okay. So an occluded front happens fast. A stationary front holds weather conditions for a long time. And it's all because of what's actually happening during an occluded front. What's actually happening during a stationary front. So let's put this in orange. This is going to be the picture that goes in your fat row, in that box where you made it larger than any other one. So let's look at an occluded front on a weather map. So what we see here are two examples, or actually two weather maps here, and each weather map is showing the symbols for fronts. This is how a meteorologist will explain to us how weather occurs, or why, where a front is. What we see here this front is different from this front. Look here, this purple front is different than this red and blue front. Each of these represents symbols for frontal boundaries that happen in the United States. So, in our notes, we're going to go back to our chart. And a warm front is going to be an arc like this with half circles appearing. And when you have time, you'll want to color those in. A cold front is blue with blue spikes coming from it. And it's in the downward position because warm rises, cold sinks. Color those in when you get a second, get a chance. The stationary front is a standoff between a warm air mass and a cold air mass. So you will see both symbols going in opposite directions. Be sure to color those in the correct colors when you have time today. An occluded front is usually represented as purple because those temperatures mix. Blue and red make purple. And we're going to have our semicircles and spikes right beside each other. What I want you to do, I will not release the frontal boundary, the fronts assignment until later on today because most of you were not able to get your notes done. I want you to make sure you get your notes done first, and then you have time to complete your assignment as you only get 2 attempts. I want to make sure you're able to finish your notes, study those notes, and then you'll have your review of your frontal boundaries assignment, and it'll be open to you today at 2 o'clock, okay? It won't be due until tomorrow. Remember, you don't have any classes in the morning until 9:36, so that's a perfect time for you to get your frontal boundaries assignment done and start looking at your study guide, which I'll also release later on tonight. I hope everyone has an amazing day. Ms. Neville will see everyone here back at 12:28 tomorrow. Bye.
Bye.
Bye, Miss Neville.
Bye.
Bye. Bye, Miss Neville.
Goodbye.
Bye.
Bye. I'll see you tomorrow.
Miss
Bye,
Neville.
young lady.
Bye.